All right, so there we go. We have the URL shared for this live stream. And what we'll do today is we're going to go over a practice exam because next Thursday is going to be our first exam. Okay, so make sure that you mark your calendar next Thursday. During the lecture time, we have our first exam. So the exam is going to start at 5:30 and it's going to end at 6:50. All right? So we cannot spill over to the lab time, so it's really just the lecture time. All right? So that's taken care of. The record is on, we are streaming. And what we'll do is we'll take a look at the exam from last semester. Okay. And we'll go over this just kind of slowly. If you guys have any questions about any points of the, I consider this our practice exam, okay? But it really is the exam last semester. So it's kind of realistic in a way. Do we have any questions before we move on? You all good? Okay. So I'm going to start to pass the roll sheet for today. Just initial your name again, next to your initial from last time. So hopefully I see most of you having 2 initials by the end of today. All right. So this is from last time, from last semester. So a lot of this has to change, like the time, the room, the date, those all have to change. But this part here is going to be the same. It's open book and open notes. So anything that is on paper, you can bring it, okay? You can bring a book if you find a book that you feel, okay, this is exactly what I want because it talks about carry loggerhead adders or something like that. You can bring that, okay? You can bring printouts of the modules if you want to. You can bring your own notes, okay? Some of you have been taking notes in class. You can bring that with you. Or if you review the video that I have been recording for this class and you feel that one particular screenshot, such as the number wheel, okay? You feel that, okay, I kind of like that presentation. You can freeze the frame, print, just kind of do a screenshot, crop out the portion that you want, put it on a piece of paper. You can bring that too. So as long as it is on a piece of paper and you prepare that yourself, well, you don't have to prepare that yourself, okay? If you know someone from the previous semester and that person says, okay, this I find is really helpful in tax class, you can bring that with you, okay? Practice exams, you can bring that with you, okay? The only thing you cannot do is to share this kind of material during the exam. So let's say I forgot to bring my notes, okay? I spent like 40 hours, to prepare, and I totally forgot to bring it with me. I cannot ask my fellow students to say, okay, I forgot to bring the module, that talks about signed versus unsigned numbers. Can I take a look at yours? That cannot be shared, okay? Not during the exam. Now, before the exam, if you guys want to sit down and work on some material together, that's perfectly okay. Not a problem. So we kind of clear on what you can and cannot do with the stuff that you bring to the exam. Okay. You can bring a calculator if you want to. So you can even bring a calculator that can do binary and hexadecimal stuff if you want to, which basically means the questions will not be asked in the format that those calculators will be of significant help. It would still be helpful, maybe, okay, but it's not going to be that significant. Sorry? Yes, that is correct. So individual assessment, okay, just make sure that everybody work on his or her individual answers, okay, because if I discover somebody's answer is not coming from that person and instead it is copied from somebody else, I would have to report that to the discipline officer at ARC. So and I don't, even the first case is going to be reported. So I'm hoping that I would not find any cases like that. Okay, occasionally I do find cases like that, and it would be unfortunate. You want to bring some additional sheets of paper in case you want to write your answer on a separate sheet of paper. There can be many reasons, okay? Some people write down an answer and go like, no, this is not the answer that I want. They cross it out, so now they don't have any place on the exam itself to write the answer. So bring some extra sheets of paper, and I really don't like the ones where you just kind of tear out of a binder, because the edge makes it kind of difficult for me to feed it through the scanner. So whatever paper you use, make sure it has a straight edge when you turn it in, okay? You can bring a pair of scissors if you want to, just kind of make sure that it's clean and straight when you turn it in. If you do decide to use extra paper, make sure that your name is on each sheet of paper, as well as to what question that sheet is corresponding to. So this way, if I do, mix it up, when I collect the exams, I will still be able to sort it out and say, oh, this piece of paper goes along with that exam, this sheet of paper goes along with that exam. So you want to make sure that I don't lose track of that. Write legibly. If I grade something because I cannot read what the answer is, or I see this is a 0, and then someone after the exam says, no, Tack, this is really a 6. See this little thing that's sticking out on the left hand side? It's really a 6. I cannot do retroactive points like that. Okay, if I see a 0, I would look at it as a 0 and grade it as a 0. Okay. So you want to write legibly. Okay, make sure that I won't misinterpret your answer in other ways. Make your answers as complete as possible, which means if there are steps to show your steps. Okay, don't just give me the final answer. Show me all the steps that it takes in order to get to the answers. Okay. All questions have equal weight. This is done so that you can quickly evaluate and find out which question you want to take on first and which one you want to take on second, and so on. Why do you think that is helpful? What if I make it so that some questions have more weight and some questions have less weight?
Some questions have more weight, and you look at that question and can't answer it or don't understand it, and you're going to be out those points. Versus if they're all equal weight, you can prioritize, maximize your points.
Yep, you can. So if they all have equal weights, then all you have to do is to evaluate. To me, is this the next easiest question? Because you want to answer the questions that are easiest to you first, and then move your way to the more difficult answers. Now, you can say, but Tack, can't you just sort the questions for us? So you put all the easy questions first and then the hard questions at the end. I cannot, because it's very individual. Some people may feel question number 2 is totally the easiest question of the entire test, and some other people will look at question number 6 and go like, no, that one is so much easier. So it all depends on individuals. So I cannot pre-sort by difficulty. You kind of have to do a quick scan at the beginning of the test, find out how you would rank the difficulties of the questions, and then start with the easiest. Okay. Some questions may cross pages. Be sure to read and answer the entire question. I try not to do that. Okay. The way I set up the questions should not have something like that to happen. But still, okay, just watch out and make sure that you read the questions carefully and not miss like 1/2 of the question because it's on the next page. The exam accounts for 20% of your final grade. So, that's from the syllabus, but I just thought it would be kind of useful to put it here as well. Do we have any questions on the first page of your exam? Because your first page is going to look very similar to this other than the time, the date, and the location. Yep. Yeah, you can bring a clipboard as long as there's space, to accommodate that. Yep. So anything that's not electronic, is fine. But psychic paper is not okay. Because with psychic paper, you can just show it to somebody else and go like, so what do you see? Oh, I see a question, or I see the answers, right? Because it's psychic. If you don't watch Doctor Who, ignore that joke. Yeah. Huh? Aha. That is a good point. I don't want psychic paper. I want psychic projector. So it depends on whose mind the psychic projector is reading, right?
Well, psychic paper reads whoever's reading your mind, right?
Yes.
So a psychic projector would read whoever's
So I would need you guys to put on your psychic blocking glasses. Then I'll be looking at the paper, so it only picks up from my mind, right? All right, so this is question number 1, and I tried my best so that you know, where you are in the test. So you can see it's question 1 of 6 to remind you that there are 6 of these. So this also brings up another point. Okay, you might want to time yourselves. Okay, if there are 6 questions and you have 80 minutes, so you might say, maybe I should spend no more than 10 minutes on each question. Okay, because if you spend only 10 minutes per question and there are 6 questions, it will only take 60 minutes, right? So you got 20 minutes, you got what? Yeah, you got 20 minutes left, which means, then you have extra time to work on the more difficult question. But by that time, you would have answered all the easy ones already. So you have picked off all the easy points, and now you just work on the more difficult points. Because the worst thing is you spend too much time on the difficult question, and then the easy questions you somehow missed. You just didn't have time to answer those questions. That would be bad. Okay, so this is question 1 of 6. In the following space, so I usually would give you the space to write down your answer. Fill in the blanks for a 5-bit subtraction so that the subtraction yields the indicated Q bits. And you can see the rows are all labeled. Okay, we got X, Y, Q, T, and D. Same letters in the same notation as in the notes. Okay, be sure to explain how you get the values and note that the solution may not be unique. In other words, in certain cases, there may be several possible answers. You just have to give me one that works. Okay, so are we understanding what the question is asking? Yep.
Do we have to explain why we got each value?
You can just do a general explanation, like just say, okay, this is the result of this, and only this will give me a result of that, and so on. So I will show you an example. So as I answer this question, I'll show you what I mean by an explanation. Okay. So first of all, if this is the first time you see questions like this, you go like, but that's exactly the opposite of what we do in class. Because in class, I would give you the X and the Y, and then we work on the Q and the T and the D. And the answer is yes, that is intentional. I want to give you something that you haven't seen, but if you understand the concepts, you'll still be able to work it out. Okay, so that's kind of a common thread of all of my exam questions. Okay, it will test whether you can apply what you have learned, but the actual problem may not be something that you have seen before. Are we good so far? So we're going to look at this and go like, okay, how do we get started with this? So if I were you, okay, I would just look up the definitions of the terms that I need to answer this question. So this is about subtraction. It's about binary subtraction. So I would definitely try to look up all the definitions. So what definitions are we talking about? How do we get to the D bits? The D bits are the R of the Q and the T bits, right? That's the definition. How do we get to the Q bits? It is the R applied to the X and the Y bits. So that's the easy one. The more difficult one is the T bit, okay? Because the T bit, this is, okay, other than the least significant T bit, the other ones rely on 2 B bits, okay, borrow bits. So you have to kind of remember all of that stuff. And it doesn't hurt to write down the definitions that you need to use for 2 reasons. One, if you write it down, it is right here. So when you think about how to approach the problem, the related definitions are right there in front of you. So that helps. 2, if I choose to give people partial credit, because at least they know what definitions apply to a question, now at least you get some partial credit if that is all you have time to write down. Is that okay? So we can do that here. We can say Qi is R of Xi, Yi, And we know di is the r of qi ti. Ti plus 1, okay? And all of this, you can look it up in the modules, okay? So there's no need to actually write down the definitions here, but you might want to write down what I encourage you guys to put as a part of your answer, okay? So I will share this document with you too, okay? When I'm done with this, I can upload it so that you guys can have a copy of this. So Ti plus 1 is the kind of the tricky one because it is the b of xi, yi, or the b of qi, ti. Okay, so those are the definitions that we need in order to answer this question. Okay, okay, so now we have the knowledge. Okay, we have the definitions. The next thing is how do we troubleshoot? Okay, in other words, from what we are given, how do we figure out the things that are missing? Okay, so that's the next step. So we know the d bit is a 0, and we know the q bit is a 0 over here. So what value of the t bit do we need in order to have a d of 0 when the q is already known as a 0? It's a 0, okay? So you put a 0 here, and if in an explanation, you can say 0 exclusive or 0 is 0. Okay? That's a totally legitimate explanation. Is that okay? So we can work this out pretty much the same way. You can put a 0 here, and then in your notes or in your explanation, you can say 1 exclusive or 0 is a 1. So if you want to kind of save your time and just give me the truth table of exclusive or, that's fine too, okay? Because that applies to all of the R results, okay? So by that means I can also work this out, I can work this out, I can work this out. Did I make a mistake? Oh, that's a 0, right? Okay, so let me fix that one. This one is a 1, this one is a 1, and this one is a 0. Thank you. Because one exclusive or with 1 is a 0. Are we good so far? So we can now go back and say, can we work out x and y using the same method? Well, it gets a little bit tricky. Because the x and the y, sometimes this is not enough, okay? Because what will give us a 0 as q? Well, 1, 1 will give us a q of 0, but 0, 0 will give us a result of 0 as well for q. So in this case, you can choose either one, because we really don't have a way to differentiate which one will give us the correct answer, okay? So you can say 0, 0. You can say 1, 1, and for both of those, I will give you your full credit because they are both correct answers. Are we good so far? So the next one has got a 1. So if the exclusive OR result is a 1, there are also two cases that can make it happen. We can have x being a 0, y being a 1, or we can have x being a 1 and y being a 0. So you might think, oh, we can choose either one. We cannot. In that case, we cannot choose either one because now we have to look at the borrow over here. Exactly. So we have to look at this borrow, okay, and we say, what can make a borrow of 1? There are two chances, okay? There are two chances. 1 minus 0 has a chance to give us a borrow of 1, but it does not because 1 minus 0 has no borrow. So that means the only way to make this particular borrow over here is to have a 0 minus 1 over here. So now you have to mention that, okay? You have to mention because of the borrow, we can only put a 0 and a 1 over here. There's no other option, okay? So over here, you can say, 0 minus 1 has a borrow of 1. Okay? So are we still doing okay? All right. So we move on to the next column. So in the next column, we want to end up with. So again, if the result of exclusive OR is a 0, 1, 1 will work. 0, 0 will work as well. Okay. So in this case, you can choose one or the other. Okay. And then we have a borrow of Oh, okay. Okay, so you might think, but what about that borrow in the next column? What about this guy over here? There's a borrow of 1. Well, it's already taken care of because of q minus t. Is that okay? So in this case, x, y, is free to have both zeros or both 1s. Okay? So now we try to work out these two. There are no borrows. The result has to be a 1. So what is the only choice that I have? 1 minus 0. Yep. So now you can explain, in your explanation, you can say 1 minus 0 has no borrow. Because the next column also has a borrow of 0, so we have to make that happen. Are we good so far? So now we just have one last column to work on, and there are no borrows. The result has to be a 1, so that means it has to be a 1 and a 0 like that. So are we good so far? So this is what I meant when I said, it is not the same format as what we talk about this when we talk about this in class, but it uses the same knowledge to answer this question. It's just that you have to find a way to apply the knowledge in this particular case to solve this problem. So are we good so far? All right, so let's move on. Yep.
Will the test have more space to put the explanations in?
Hmm?
Will the test have more space?
Yeah, I can give you more space, but you can also kind of like just make a pointer and go somewhere like that. Oh, people do it all the time. It's okay as long as I can follow the line. It's okay. Or if you want to borrow the concept of a tunnel, you can have tunnels too. Or you can even refer to a different sheet of paper.
You can specify what bit it is too. Can be like bit 0, bit 1, bit 2, etc.
Yeah, you can designate the bits too. Yep. Because we know the naming of the bits, right? X4, X3, X2, X1, X0. So you can separate the calculations or the reasoning for each individual bit on the side. Then it's easier that way too. So as long as I can see your explanation is okay. Okay, however you want to present your, however you want to kind of link your reasoning to the answer is okay. All right, this is question number 2 of 6, and I see these as fairly easy questions, because there are only so many ways to ask questions like this. But I think I just thought of a new way to do it now. It just pops up in my head. But if I don't write it down, I cannot remember. I should look at the psychic whiteboard so you guys can all see it too. But then you'll see other things too, so maybe not a good idea. Convert the following number into a base 10 number with 2 places after the decimal point, for example, 2.24, step by step. Okay, so I don't want you to just jump to the base 10 representation. I want you to show me all the individual steps. Okay. So how do we do this? Okay, so you say 213.22 in base 5 is, so it depends on how detailed you want it to be, but what I want to know is you understand what each digit is representing. Okay, so the bottom line is I need you to tell me that the 2 is representing 5 to the power of 2s, plus 1 times 5 to the power of 1, plus 3 times 5 to the power of 0. So most people get this part. Okay, this is the kind of easy part. Most people in the past, okay, are usually when they have a problem, it's a problem with the digits to the right-hand side of the point. Okay, but the reality is they are not really special. If you know how to count down from 2 to 1 to 0, what do you think is going to be the next power? -1. Exactly. So it's 2 times 5 to the power of -1 plus 2 times 5 to the power of -2. Okay? I need to see this. Okay? I need to see that you understand what each digit is representing. Okay? So now the next step is, okay, that's 50, and that's 5, that is 3, That is 2 divided by 5, or if you want to say 0.4, that's fine. And that one is 2 times 0.04, so that would make it 0.08. Okay? Now, if you need extra steps, to say, okay, I need one extra step because I want to show that 2 divided by 5 is 0.4, and 2 divided by 25 is 0.08, that's fine. Okay? Having extra steps do not hurt. Okay? Yep.
Do you care if we use mixed numbers?
Sorry?
Do you care if we use mixed numbers? Do you care if we use mixed numbers?
Mixed numbers. Well, as long as the final answer has 2 places after the decimal point. So in between, you can use additional steps, you can use fractions, you can use mixed numbers, but when you get to the final answer, I need it to be a decimal number that has 2 places to the right-hand side of the decimal point. Okay. So now I add up all these things, I get 58.48. So that would be the final answer. Now, because I have already used this method of asking this kind of question or testing your knowledge about this type of thing, I probably will have a slightly different way of asking about the same thing. So it will still be the same knowledge that I'm testing, but the format of the question may not be the same. Are we good so far? So there is such a thing, at least in my classes, there is such a thing of overstudying past exams. Because then people get too locked onto a particular way of asking a question, and then some people cannot maintain the flexibility of, okay, I'm separating the knowledge from the problem-solving part. And those two kind of become merged, become one thing, then they can only solve the problem when it's presented in a particular way. So I just want to warn you guys and say, okay, don't expect the questions to be asked exactly the same way. Yep.
I'm curious how you ask this question, if you have another way that it's not getting on the exam that you could, like, would it be from going from, base 10 to like a base 5?
So I just thought of a way to do it, okay? So I might give you something that is incomplete, okay? So there may be some missing digits in it. And I say, okay, but it is really representing this value in base 10. So now your task is to go back and say, what are those missing digits?
Okay,
Right?
that makes sense then.
Yep. But it's still really testing the same knowledge, but you have to apply the knowledge in a slightly different way to solve the problem.
Thank you.
Sure. So are we okay with this? Okay. So question number 3 is really just the reverse of this. It is still testing whether you understand the concept of what is a number, and what value it is representing. So question 3, says, convert the following base 10 mixed fraction, 15 and 7/9, into a base 3 number with decimal places step by step. Okay. So it's kind of the reverse of the first problem, right? Except this one has mixed fraction instead of a decimal number, okay? So now you have to ask the question, what is a base 3 number? What does each digit of a base 3 number represent? 3 to the power of something, right? It is representing the quantity of a power of 3. That is the job of each digit of a base 3 number. Are we good so far? Okay, but how do we get there? Okay, so we want to look at this value, which is represented as a base 10 fraction at this point, and ask the question, how do we come up with a sum of quantities of powers of 3 to represent exactly the same thing? That basically is the question. So you look at this, okay, and you say, you can even have a table, okay? There are many ways to do this. So you can have a table that has all the powers of 3 kind of written out, okay? So you can say 1 is a power of 3 because it's 3 to the power of 0. 3 is a power of 3, 9 is a power of 3, and then the next one is 27. And you can stop at 27 because the value that is given to you is only 15 something, so we know that 27 should not be needed, okay? But on the other side, you also have the fractions. So you have 1/3 and 1/9. And if you want to, we also have 1/27th, but we kind of know that that is not needed because the mixed fraction given to you only has a 9 as a denominator. So we probably do not need to get to the 27th. So is that okay so far? I just enumerate all the powers of 3, and then I go down the list and ask how many of this do I need? Now, there's only one way to go wrong in this process, which is starting from the wrong end. Okay? Because if you start from the end of 1/27th, then you're going to give me a huge number that is not going to be correct. Is that making any sense? So you want to start from which end? From the left-hand side, from the most significant digits. So you can look at 27 and go like, nah, there's none of those. Okay? It's fine. Leading zeros do not hurt. Okay? It's all good. Yep. No. You do not need to have leading zeros. You do not need to have trailing zeros unless the questions specifically say how many places to the left or how many places to the right of the point. If it does not specify, then you do not need to have leading nor trailing zeros. Okay, so how many 9s do we have in 15 and something? We only got one of those. So once the 9 is taken care of, we have 6 left, right? The quantity left is 6. But the next power of 3 is just 3 itself. So how many 3s do we have in 6? We got 2 of those. So once we have taken care of the 9 and 2 3s, we have just taken care of the entire 15. So there's 0 left, so there are no 1s anymore. Does that make sense? Okay. So now we put a point here, because the whole idea of the point when we represent a number is only here to separate the power of 0 versus the power of -1. That's the job of the point. It's really just like the comma. It's really only there so that we can visually see, okay, which digit is corresponding to 3 to the power of 0 here. Okay, that's the job of the point. So now we look at 1/3. We ask how many 1/3 do we have in 7/9? We got 2 of those. So once we have those taken care of, which is 6/9, right, we only got 1/9 left. So we have 1 of 1/9, and we have 0 of 1/27th. And that's the answer, right there.
Is that enough work?
Sorry?
Does that show enough work if we do it like that?
So if you want to show the work, I would add this to show that these are powers of 3, and so on. Yeah. So do we have any questions about number 3? Are we good with number 3? All right. Number 4. So number 4 is, in this question, we are considering the carry bit K8, okay? Using the carry look-ahead technique, which conjunction term of K8 has exactly 4 terms? In other words, it has 4 components in the conjunction. In the following space, explain your reasoning and derive that conjunctive term, which is basically just an and term. For example, for K3, the conjunctive term P2, P1, P0, K0 has exactly 4 terms. So I'm asking, which term, when you look at the carry look-ahead method of calculating K8, has exactly 4 terms. Okay? So how do you solve this problem? How do you get started? Okay, that's the first thing, is how do you get started? Definitions, right? Okay, you look up definitions. So I'm assuming that you have that note with you with that kind of awful looking, expression. Okay, so we'll go ahead and look at the expression. So let's go back to our browser, go back to the notes, and that is in binary addition. So right here. And it's in section 6, kind of the end of section 6. All right. All right, this is the stuff we're talking about. Okay, well, you guys are lucky. At least I added extra parentheses for this time, for this year. So now the question is, okay, first of all, I'm trying to figure out K8, right? So that means n equals to 7. Very good. Okay, so n equals to 7. So now we have I going from 0 to 7. And then j is a little bit tricky because depending on the value of I, j, the starting point of j changes, right? And then on the other side, we have an entirely separate conjunction that goes from 0 to 7 because n is 7, okay? So you just look at this and go like, we are pretty sure has nothing to do with k0 and a whole bunch of p's because that thing is going to have how many terms? It has 9 terms because I goes from 0 to 7. That gives us 8 terms already. And then plus the k0, which is ended with that big other end. So now we have 9 terms in that conjunction. It's not the answer, okay? So the answer has got to be one of the things that we generate over here. Is that okay? So now you ask the question, what j is going to give us exactly 3 items of conjunctions of p's because we have that g of I on the outside to add up to 4 terms. Do you see where I'm going? Okay? We know n is 7. Okay? So that means if j's start from 7 and it goes to 7, we got 1 term. Right? When j is 6, we got 2 terms. When j starts with 5, we will have exactly 3 terms. So the question is, how does j start with 5 when I equals to 4? Okay, so we now lock down the value of I. I has to equal to 4, which means it starts with g4, right? And then p terms start with ji plus 1. So if it is 4i, so we have g4, p5, p6, p7. And there are exactly 4 terms. That is the answer. So the explanation is kind of what I just said. You just kind of look at this whole thing and say, what is the starting point of j that will give you that answer? From the starting point of j, you lock down the value of I, then you know what conjunctive term will give you the answer. Yes? Because I want a conjunctive term that has exactly 4 things in it, right? So that means this thing, okay, the conjunctive term inside here, okay, so that means this part here has to give me exactly 3 terms because that is ended with g of I, right? So if I know that this term has to give me exactly 3 items and n is 7, then I can work my way back and say, oh, j has to start with 5 because we have 5, 6, 7. That will give me 3 terms from that conjunction. And then when we end that conjunction with g of I, then we have exactly 4 terms. Mm-hmm. Yep.
What's the difference between the triangle that's facing downwards and the triangle that's facing upwards?
I will not answer that question. It's something that we talked about in week 1-ish or week 2. It has to do with the symbols for conjunction and disjunction. Which one do you think is conjunction from the explanation that I have talked about so far? No. This is conjunction. That is disjunction. Yep. So I strongly recommend you to read all the modules because the mathematical symbols were discussed in one of the modules. Yep.
Can you repeat the answer?
May I answer that question with it is being recorded? Is there a specific part of it that you want me to go over because it wasn't clear the way I explained it? Okay. But is there a specific part that you want me to kind of address? Like how I come up with the I?
Why can you disregard K0? Is it not part of this conjunction?
No, because it has too many terms. Because this loop here, I is going from 0 to 7. So if you count, 0, 1, 2, 3, 4, 5, 6, 7, that has 8 terms already. I'm looking for a term that only has, I'm looking for a conjunction that only has 4 terms. So it cannot be that. If I were to ask, okay, give me a term that has, give me a conjunction that has 9 terms, then this would be the correct answer because it has exactly 9 items in the conjunction. So are we doing okay so far with this question at this point? Okay, so it really relies you on being able to read the expression, understand what it means, okay, and and also what is a conjunction and what is a disjunction. That certainly helps, and also the fact that this plus is not really an arithmetic addition. It is how I use a plus to how I overload a plus to also mean disjunction. So are we doing okay with this question? Can we move on to the next one? Okay, all right. But it is all getting recorded, okay? So if you have one little thing that you want to review, okay, it really helps to kind of keep track of the time. So this way you can just kind of fast forward to whatever the current time is, and just get to that particular question, okay? So we are moving on to question number 5. Question number 5. In this question, step by step, derive the base 10 signed value represented by the following 6-bit binary number. Okay, so that one is, you just have to plug in some of the expressions and go, okay, that's what it is. Okay, yep.
Sorry, one quick question for question 4.
Let me go back to show question 4.
Just for our explanation, we kind of write out that equation.
I would quote that equation. I would definitely just kind of repeat the equation here. Yeah, I would just kind of quote it here, and then you just say, okay, we need exactly 4 terms. So what we are looking for is this thing, this portion, to provide 3 of the 4 terms because there's an extra one outside. So you can use words to explain that. It doesn't all have to be in mathematical symbols. I just need to know what goes through your mind when you answer the question. Are we good? All right. So getting back to question number 5. So question number 5 is asking you what is the signed value represented by 100,101 in base 2. So there are several ways to answer this question depending on which definition you feel more comfortable with. So we talked about 2 concepts that can be helpful here in the modules, okay? So I'm going to go back to the modules and kind of point out which module contains the information that is kind of helpful. So the first one is signed representation, signed value representation. That one is helpful, okay? Because that's kind of the title of the module. The next one is actually helpful as well, okay? So I'm going to open up both of those so that you can see, how these 2 are related. Interesting. I haven't regenerated this page for a while, and that's why it doesn't have that table of contents at the beginning. So with this one, you can go to the signed representation. It talks about the number circle. It talks about the sign bit, and it talks about 2's complement. Okay, so you can use 2's complement to solve this problem. So the way you use 2's complement to solve the problem is you look at the bit pattern, okay? And then the first thing you do is to say, well, is this representing a non-negative value or is it representing a negative value? Okay? It's representing a negative value because the sign bit is a 1. Okay? So write that down in your explanation. Okay? The sign bit is a 1, the value represented is negative. Okay? That's great. But the problem is you don't know how negative it is. Right? So if you think you have the time to draw me a gigantic number circle to work this out, I would actually count it as a correct answer. But by doing so, it may consume quite a bit of time. And the chances of making a mistake as you count backwards is there as well. So I do not recommend that method. So what is the other way? Okay, I know this is representing a negative value. I just need to know the magnitude of the negative value. What do I do?
Just take the sign bit off and calculate what that is in base 10, right?
Nope, 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 nope.
You switch all the ones to zeros to ones first.
You apply 2's complement, okay? You apply 2's complement because 2's complement to a binary number is the same thing as arithmetic negation, right? So if I already know this is a negative value, if I take the 2's complement of it, then I know how negative it is. And then I know the actual value that it is representing. So let me just write it down instead of just talk about it. I'll write it down, and I need to find, yep, there we go. Okay, so we say this is, you don't even have to give me complete sentences as long as you indicate this bit tells us the value is negative, it's okay. Okay, so now we can say, we want to look at, so 100, 101 in base 2 is the same thing as, now this part is really important because if I claim 2's complement is doing exactly the same thing as arithmetic negation, that means if I put an arithmetic negation on the outside and the 2's complement on the inside, it should cancel out and I should get the same thing back, right? So that means I can now re-express this as the arithmetic negation of the 2's complement of the same bit pattern. Because 2's complement is considered the same operation as an arithmetic negation. Is that okay? Because this is really important. Okay? So then I look at this and go like, okay, keep the arithmetic negation on the outside because that's the whole idea. I need to know how negative the value really is. So now you just have to sort out what is the 2's complement of 100, 101. And we look at this and say this is the same thing as 1's complement of the same bit pattern plus 1. Okay? And then we look at this and say, oh, okay, let's flip all the zeros into ones and all the ones into zeros. And then we end up with 0, 1, 1, 0, 1, 0 in base 2. And then we have to add 1 to it. So it is the arithmetic negation of 0, 1, 1, 0, 1, 0, 1, 1 in base 2. And it becomes, so now you have to convert it into base 10 because that's what the question is asking. So if somebody stops right here, that would definitely not get the full credit because the question specifically asks, derive the base 10 signed value. This is the signed value, but it's not in base 10. So we have to look at the base 10 value here. So what you do is you just look at all the bits and say this is a 1, this is a 2, we have a 4, we do not have a 4, we have an 8, and then we have a 16. So we have 24 plus 3, which is 27. So it's negative 27 as a base 10 number. Is that okay? That's one way to do it. Remember, what is the other way to do it? So the other way to do it relies on another note that I have written, but this time it is in the module that talks about binary number comparison. Okay, so when you look into that particular module, there is a sigma expression that tells us what is the value of a signed number. And I just have to look for that. There we go. There. Okay. So the derivation is not important. Okay. If any one of you actually dug through the derivation and understood the derivation, great. Okay, if you look at this derivation and go like, I don't want to dig through that, it's okay, okay? But the bottom line is, do we understand the final form of this expression? That is important, okay? You have to be able to read this part. So m is the number of bits, okay? So in our case, we have a 6-bit number. M equals to 6 in that case. So what you do is you sum up the digits, okay, x0 all the way up to x4 times the respective power of 2. But wait, Tech, that only accounts for 5 out of the 6 bits. You'll be right, okay? We only look at the least significant 5 bits and figure out the unsigned value of those 5 bits, okay? And then what we do is now we look at the most significant bit, which is bit m minus 1, or in this case, bit 5, okay? If bit 5 is a 1, we subtract 2 to the power of 5 from that value. Is that okay? So let's see if this works in our case, okay? We just sum up the least significant 5 bits, and then we subtract the power of 2 corresponding to the most significant bit. So we look at 100, 101, and it's pretty easy, right? So we got a 1, we got a 4, so we say it is 1 plus 4. But then we also have to look at the most significant bit. It is a 1. But the power of 2 corresponding to the most significant bit is not added. It is subtracted from the rest. So now we have to say subtract 2 to the power of 5, which is 32. So now we have 5 minus 32, and it comes to the same answer. Okay? But if you want to use this as an answer, then you have to give me the definition that I just showed you earlier, which is this particular equation. You don't show the derivation, just v of x, which is a bit pattern, equals to the sigma blah 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 minus x5 in this case times 2 to the power of 5. So you have to show me that you know which equation or which expression is applicable when you apply it. Question?
Is writing down the equation an explanation, or do you want us to go through?
So if you write down the equation and then you say when we apply this equation to the bit pattern, we get the following result, I will count that as correct. But you probably want to expand it anyway, because unless you can keep track of a summation in your head really, really well, it doesn't hurt to write it down. So when in doubt, okay, just write down more steps. Does that make sense? Okay. So do we have any more questions about number 5, which is looking at a bit pattern and figure out what value it is representing? No questions? Okay. So there can be alternative forms of that question. Okay, I can give you something exactly the opposite. I can say, okay, here's negative 25. How do we represent negative 25 using 7 bits, signed? Okay, then you have to show me how you derive that. Okay, I can show you a binary bit pattern that has missing pieces, and say I want this eventually to express that value over there. What are the missing pieces? Okay, so that's another way to ask kind of the same kind of question. All right. I mean, there really are only so many ways I can ask about, quiz you on a certain specific knowledge. So each year is a challenge. Yes?
Sign bit is bit number 6.
So the sign bit is bit 5. The most significant bit is bit 5 because we start counting from 0.
Okay, 0 means it's negative.
Sorry?
0 means it's negative.
0 means?
Like a sign.
So okay, let me go back to Zerno. Okay, so in this case, this is bit 0, this is bit 1, bit 2, bit 3, bit 4, and this is bit 5. Because we start counting from 0, because the bit position tells you what power of 2 it is corresponding to. So we good with this one? Any other questions? No other questions? All right. So here's question number 6. In this question, you are given that the subtrahend, in parentheses y, as the following 6-bit binary number. So we know what the subtrahend is. Step by step, find the minuend x such that the subtraction x minus y barely sets the overflow flag. This means that if x plus, okay, with a subscript is x plus 1 and x minus is x minus 1, then one of the subtractions, okay, x plus minus y or x minus minus y, results in a subtraction such that the overflow flag is not set. Okay, do we understand the question? Do we understand what I mean when I say barely? Using the definition that is shown here. Okay, what is x plus? X plus 1, x minus 1, okay? And I want x minus y to set the overflow, but I also want one of these two, okay? Either x minus minus 1 or x plus minus 1, excuse me, x minus minus y or x plus minus y not to set the overflow, okay? So how do you find the answer to this question? And I already tell you what the subtrahend is. The subtrahend is 0, 0, 1, 0, 0, 1. So how do you figure out the answer? Okay, so you just kind of write it out first, okay, and re-specify the requirement, but specific to the bit pattern that we are given, okay? So you say x minus 0, 0, 1, 0, 0, 1 would end up with overflow being a 1, okay? X plus 1 minus 0, 0, 1, 0, 0, 1, or x plus 1, x minus 1, okay, so we can undo that, or x minus 1 minus 0, 0, 1, 0, 0, 1. So one of these two will give you an overflow of 0. Is that okay? So, yep.
Is it one or both?
Hmm?
Is it going to be one or both? It has to be one.
What has to be 1?
Because, I mean, the addition, or the x plus 1 or the x minus 1, is it going to be only 1, that the overflow flag is 0?
Okay, so according to the definition here, if you can find a case where they're both zeros, it's okay, because the question asks, just give me a case where x minus the pattern gives you overflow, and at least one of the other two subtractions, or one of the other subtractions, result in not overflowing. So you can interpret either way, but in the end, only one of them, up to one of them, would not overflow. The other one will continue to overflow. Okay, so that's what the question is asking. So now how do we answer this question? As it turns out, this one has a really easy, answer because of the way I phrase it. Okay. Mm-hmm.
The overflow flag is set if either both the sign of the subtend and minuend are the same, and so if the subtend and minuend sign bits are the same and the final sign bit is different, that's when it's overflow, right?
Yes, the overflow means the minuend sign does not agree with the sign of this subtrahend and the difference. So the subtrahend and the difference have to have the same sign, and then the minuend has to be different.
Okay, so we then need to, so we can now assume, so that means we know that in order for this to overflow.
Yes, so that's the proper way to answer the question. Okay, very good. So let me just write it down because I know you kind of know how to work this out, but it's good for me to kind of show the class how to work this out. Okay, so you basically start with some bit patterns as x. Okay, and then you say I want to subtract 0, 0, 1, 0, 0, 1 from it. So this is y, and then we got the usual q, we got the usual t, and then we got the usual d over here. So the only way to set the overflow in this case is you have a 1 over here and a 0 over here. Okay? So when you have a 1 as the sign bit of x and a 0 as the sign bit of y and then a 0 as the sign bit of d, that will give you an overflow. Okay? So now the question is, how do we fill up the other digits? Okay? Okay, so once again, this is relying on how well do you know the definitions of each row of these things. Question?
So I was just saying the only way is, so either x plus 1 or x minus 1 built into this pattern is going to have to result in the sign.
But this time you have to fill it in from left to right.
Yeah.
So let's go ahead and do this, okay? So let's go ahead and see if we can fill in all the blanks kind of in the reverse order. And we'll try to make x marginal, right? We want x to be barely setting the overflow flag, okay? All right. So 1 minus 0, we know what that is, okay? We know for sure that's going to be a 1. But we want the last one to be we want the d of this column to be a 0. So what has to be the t? The t has to be a 1. So at this point, this column is completely deterministic. We don't have alternatives to choose from. Okay, so from this point, we kind of go back to the previous column. Okay, we now go to the second last column. So the second last column is a little bit harder to work out, okay, because you do have some choices. So since we have a borrow over here, that means we have to see a 0 minus 1 somewhere. But this is a 0 here, so the 0 minus 1 has to be here. Does that make sense? So now we say, okay, because this is a 0, the subtraction of this part can never give me a borrow of 1. So forget about it. My subtraction that it has a borrow has to be this. Oh, but wait, if I know the q bit is a 0 and the y bit is a 0, we lock down x to be 0 as well. Okay, very good. If I know q is a 0, t is a 1, I also know what d is supposed to be, right? Now, that is not really needed, okay, because I just want you to figure out what x is. You don't have to figure out what d is. So you can leave it blank if you want to, but just for completeness, I'm going to also answer the question. Okay, so now we look at this borrow bit, and we say, oh, we need another subtraction that has a borrow. So this time, you have to think kind of a little bit harder, because I could make this bit a 1, okay? So let me just kind of propose where I can put a 1. So I can put a 1 here. If I put a 1 over here, then I have a 0, 1 over here in order to make a borrow over here, right? So that's one alternative. Okay, let's show the other alternative. So the other alternative is to have a 1 over here and have a 0, 1 over here, and that will still give me a borrow of 1. So now the question is, which way is better? In other words, if I want to just barely set the overflow flag, which one is going to barely set the overflow flag? Yes? A higher x value, okay? And the rationale is? Okay. So the argument is good, okay? The way you're going is good, okay? The way you're reasoning this out is very good, because the real question that we have in this case is, should we use a 0 here or should we use a 1 here? Okay, we can choose. If you use a 0 here, then x is a more negative value. If you choose a 1 here, then x is a less negative value. It is still negative, but it's less negative, okay? So now you have to say, if I subtract a non-negative value from a negative value, okay, and somehow I end up not being able to store the result, the difference, right? So should I make x larger or more negative, or should I make x less negative if I would just to barely trip the overflow flag? That is the question. So what do you think is the answer? We wanted to just barely set the overflow flag. In other words, in the number wheel, okay, so let me draw the number wheel. So in the number wheel, we know that x has to be negative, so x has to be here, okay? And we wanted to just barely set the overflow flag. So when you have a number wheel, and I'm just going to say this is 0, and this is the most negative value here, and this is the most positive value over here. When we cross that line, that is overflow. Okay? So we already know how much we are subtracting. We know how many ticks we are moving counterclockwise. The question is, if I just want to barely go from here to here, and I know the quantity I'm going from here to here, do I want to start with something that's over here and it goes over, to this side, or do I want to go for something that just goes like, up, up, we just overflowed? The latter, right? So that means we want a value that is not as negative. And in order to have a value that is not as negative, we want a 1. Does that make sense? Because if you want to kind of have a guaranteed overflow case, easy peasy. Just rest here. Right? If I'm already here, which is 1 followed by all zeros, as long as I subtract anything that is at least 1, it's going to trip the overflow. But that's not barely overflowing. That's like overkilling overflow. Double O. I think that's why they call James Bond 007. Overkill overflow 7. Are we still okay? So getting back on track here, because I'm seeing explosions and James Bond already. So I have to reel my own mind back, to here. So do we understand why we have to choose a 1 here? Okay. So now it's good. So now that we know why we are choosing the 1, and we just go ahead and I need to put it here. Erase the circle, and this time we actually put a 1 over here. So 1 minus 1 is a 0, so we need a 1 here. And it's kind of about the same thing, the same argument with the rest. This one says we need to have a 0 minus 1. The 0 minus 1 cannot be coming from here, so it has to come from here. Okay? But if this is a 0, okay, can you guys see when I hover over? Okay. So if this is a 0 and this is also a 0, that locks down this has to be a 0. Okay? And since we also have a borrow here, and this is a 0, we don't have a choice. 0 minus 0, and then we have 0 minus 1 over here. And then because this is a 1, and this is also a 1, so that means, Now, exactly, this time you have to be careful because this is guaranteed a 0 to begin with. So we have to fill that in as a 0 first. Now, if we know that is a 0, that means we cannot rely on q minus t to get me a borrow. So this time it has to come from here. 0 minus 1 give me this borrow. 0 minus 0 will end up with a 0. Is that okay? Does everybody understand how I work my way back to figure out all the bits for x? Huh? Did I make a mistake? Oh, okay. I just made that mistake here. So this has to be a 1. There we go. But since I'm only asking for x, even though I mess up the q, you'll still end up with the correct x, value in that case. But now the question is, what exactly is this x representing? Okay, because I want you to kind of see, after all of these calculations, what is the value of this x? So that kind of goes back to the earlier question, right? I give you a bit pattern, and I want to know what value x is representing as a signed representation. So we can now use the quicker trick. The quicker trick is to say we got 1, 2, 4, 8. Okay, so this is 8. This is negative 32. So we have 8 minus 32, which is negative 24. Okay, so we have, let me just write down here. So x is 1, 2, 4, 8 minus 32, which is 2 to the power 5, and that is negative 24. Okay, so why is negative 24 going to work in this case? What is y? Okay, now there's nothing tricky to y. Y is just 0, 1, 0, 1, 0, 0, 1. So it is 9, right? Because we have 1, 1, and 1, 8 in this case. So y is pretty easy. Y really is just 9. So what is negative 24 minus 9? Negative 33. So now you have to go back to recall what is, if I give you the number of bits, what is the most negative value you can represent in signed representation? Okay, do you guys still remember that equation? It is negative 2 to the power of the number of bits minus 1. We have 6 bits, right? So 6 minus 1 is 5. So we can represent all the way. No, it's m minus 2 because so it's 6 minus 2, which is 2 to the power 4. No. It's just negative 1. I take it back. It's negative 1. It's m minus 1. So m is 6. So we say 2 to the power 5, and then take the negation of that. That's negative 32. So negative 32 is the most negative value we can represent using a 6-bit signed representation. And because the result of negative 24 minus 9 goes over that by just 1, that is why it barely overflows. Are we doing okay so far? So now we can, now I know, you probably do not want to do this during the test, but you can test out values, right? Because the test is, if I just add 1 to negative 24, that will give me my x plus, right? So x plus is going to be negative 23. Negative 23 minus 9 is exactly negative 32, which is the most negative value I can represent. No overflow, right? Now, what about the other one? Okay, what if I subtract 1 more from negative 24? That's negative 25. Negative 25 minus 9 is negative 34. And that's kind of 1 over, it's 2 values over the most negative value that I can actually represent. So it's an overkill if I want to look for the borderline case. Is that okay? All right. So those are the 6 practice questions from last semester. Are there any questions about any of these? Yep.
So if last time you use to check your answer, can we reason that way and use that as an explanation for our x?
You mean using this as an argument? You can use that as an argument, but you have to present your reasoning. So if you want to use this method here, then you have to tell me, okay, given that we only have 6 bits, the values we can represent using only 6 bits signed would go from 2 to the power, negative 2 to the power of 5 to 2 to the power of 5 minus 1 on the positive side. So we are looking at something that will end up with a value of negative 33. Okay? So now the question is, what minus 9 will give us negative 33? And then you figure, oh, okay, it is negative 24. But it's not done yet because you have to give me the binary representation of negative 24. So now you have to work out, okay, what is negative 24? How is it represented as a binary number? So you have to say, okay, in order to get to negative 24, it is 8 minus 32, right? So we have 1 bit for the 8, and then 1 bit for the 32. Therefore, it is 1, 0, 1, 0, 0, 0. So you can use that method to use that route, but you still have to give me all the reasoning that you go through to get to the answer. All right? So any other questions? Okay, so you guys have a choice, okay? Either way is okay with me because you still have the same amount of work ahead of you. Do you want me to release the next floating point number lab so that you can get it started tonight or not? We have covered enough topics to go over that one so you can actually get started with it. Yep.
If you don't open it tonight, when are you going to open it?
If I don't open it tonight, then it's going to be opened up on next Tuesday. So I think opening it up today is better because you have the weekend to work on it, and And also there's continuity, okay? Because if I don't open it tonight, you don't work on it, and then next Tuesday when I do open it, most of you probably would have forgotten, some of the stuff that I have talked about in terms of double precision floating point numbers. So I think to keep that continuity in your mind, it's good to get it started tonight. You still have 1 week to work on it. I mean, you still have, until Thursday, next Thursday, to turn it in. So if you say, okay, my mind is fried today, I don't want to work on it, you can still work on it next Tuesday. But except next Tuesday, we'll have another lab stacked on top of that. So should we open it tonight? Yes. Okay, all right. So I'll go ahead and open it tonight when I get to the lab, and I'll pack up as quickly as I can, and then we'll all go to the lab.